First question, considering the quadratic equation which is given here with alpha beta as its roots, and given that A has this third expression, B is the sum of the infinite GP given here, and the absolute value of alpha minus beta is 6 root 6 per K, where K is its log equation, we are asked to find the value of C by 16, right? So for this, first of all, we'll simplify the third A, which is given by, just a second, I'll switch the pen, right? So taking A to be this 49 plus 20 root 6 whole power 1 by 4, right? So this expression actually simplifies to, this is basically, wait, I'll just write 49 as 25 plus 24, and 20 root 6 simplifies to 2 times 5 times 4 roots, wait, this is 2 root 6. Right. So you get that this 5 squares to 25 and this 2 root 6 squares to 24, right? Because 2 root 6 squared is 4 into 6, which is 24. So basically this 49 plus 20 root 6 can be written as this is basically 5 plus 2 root 6 the whole square, the whole power 1 by 4, right? Which simplifies down to 5 plus 2 root 6 under root. Now we can again simplify this 5 plus 2 root 6 as 2 plus 3 plus 2 into root 2 into root 3, where it's pretty simple to see that root 2 squares to 2, root 3 squares to 3. This so this expression can basically be written as root 2 plus root 3 the whole square, and this root and square cancels to give you root 2 plus root 3, which is the value of A, right? So in this quadratic equation, the value of the first coefficient of x square, that is, I represent that by small a, is this A times root 3 minus root 2, which basically becomes, right, I'll just write it down, into root 3 minus root 2, which basically becomes 3 minus 2, which is 1, right? So you get that the first coefficient A is 1. Similarly, I'll solve for, wait, I'll solve for B here, right? And B is the sum of this infinite GP, 8 root 3 plus 8 root 6 by root 3 plus 16 by root 3, etc. Here you can see that 16 does not have a root 3 coefficient at the numerator, which is needed for me to take this root 3 out here, right? So I'll just multiply this 16 by root 3 as 16 root 3 by 3. I'll just explain this step so that you don't get confused when I write it down. So I'll write B to be 8 root 3 plus 8 root 6 by root 3 plus 16 root 3 by 3 plus dot dot dot, right? Which is basically 8 root 3 times 1 plus, okay, 8 root 3 times 1 plus this is root 2 by root 3, because root 2 into root 3 is root 6, and this divided by root 3 comes here. And this is basically 2 by 3, because 8 root 3 into 2 by 3 is 16 root 3 divided by 3, right? Plus whatever, right? So you can see that this is an infinite GP with ratio root 2 by root 3. And so this expression B simplifies to 8 root 3 divided by 1 minus root 2 by root 3, using the formula A by 1 minus R for the sum of an infinite GP, which is 8 into 3 divided by root 3 minus root 2, which is basically 24 into root 3 plus root 2. I'm rationalizing the third here, divided by 1, where root 3 minus root 2 into root 3 plus root 2 gives 3 minus 2, that is 1, right? Which is 24 times root 3 plus root 2, right? So we have gotten the value of B, right? And here we can see that the second coefficient B is basically this capital B divided by root 3 plus root 2, which is 24, right? And C, your small c, the third coefficient is basically capital C. So we have nothing to do there, right? And we are given that mod alpha minus beta is basically a 6 root 6 per K, right? Where K is this big log equation. I presume that you're all familiar with the log equations. So I'm just proceeding with log 6, 10 divided by root 5, the whole square, into I'll just open a bracket here so that you don't get confused, right? And it is this into this is square root of log to the base 6, 18 plus log to the base 6, 72, right? This basically simplifies to this is 2, and this becomes log to the base 6 of 6 into 36 in wait, this is 6 into 3, 6 gives 18, and this is 72, which is 36 times 2, right? Which is basically log to the base 6, 6 into 36, that's 216, that's 6 cube, and this is another 6. So this is, I'll represent this as 6 power 4, which is 4, right? And so this reduces to 4, and a 4 under root gives 2, and 2 into 2 gives 4. So this expression basically simplifies to log 4 to the base 6, right? This is k. And substituting the value of k here, this is basically 6 power 3 by 2 to the power log to the base 6, 4, which is, I'll write this here. This is, wait, let's not see. So this is alpha minus beta is this, right? And you know that you can simplify the base and this coefficient. So I'm just basically rewriting this as 4 to the power log to the base 6, 6 power 3 by 2, which is basically 4 power 3 by 2, which is 8, right? So we have alpha minus beta. From this, I get the value of alpha minus beta the whole squared, which is 64. But you also know that this represents, this can be represented by alpha square minus 2 alpha beta plus beta square. That is alpha square plus 2 alpha beta plus beta square minus 4 alpha beta, which is basically minus b by a the whole squared minus 4c by a, right? Where I'm just replacing alpha plus beta the whole square. This is alpha plus beta, and this is alpha beta, right? So alpha plus beta the whole square minus 4 alpha beta, you say alpha minus beta the whole square, you can easily check it out, right? And so this expression is basically b squared divided by a squared minus 4c by a, which is I've written the value of b, c, and a behind. So just loop back, right? This is 576 divided by 1 minus 4 into c divided by a, which has to give you 64, right? So you see that minus 4c, right? I don't need to write an a here, this is just 1. So you can see that minus 4c is equal to 64 minus 576, that's minus 512. And so a 4 goes here, this minus goes here, this 4 gives you 128. So c is basically 128, right? They've asked for the they've asked you the value of c by 16, and 128 by 16 is basically 8. Okay, that's the answer. For question number 2, right? I'm sorry for that. Right, question number 2. Let k1, k2 are the two values of k for which equation this has one root equals 2 more than the other. So basically, we are given that alpha plus 2. Wait, I'll write this as, right, alpha equals beta plus 2. Right, one root is equal to 2 more than the other. Find the value of k1 square minus k2 square. Right, this is fairly simple. You have alpha is equal to beta plus 2. So find alpha plus beta is basically 2 alpha plus 2, which is minus b by a. Minus b by a gives you, I'll rewrite this equation, 4x squared minus 20x minus 4 plus k squared is equal to 0, right? From this, you can easily see that a is equal to 4, b equals minus 20, and c equals k squared minus 4, where a, b, c are the 3 coefficients for a quadratic equation, right? So this alpha plus beta is 2 alpha plus 2. This is basically minus b by a. That's minus of minus 20 by 4, minus of minus 20 divided by 4, which is 5, right? So we are given that 2 alpha plus 2 is equal to 5. So alpha is equal to 5 minus 2, 3 divided by 2. That is 1.5, right? If you're comfortable with fractions, I write this as 3 by 2. Right, and so beta is equal to 3 by 2 plus 2. That is basically 7 by 2. right? Beta is equal to 7/2. We have found out the values of alpha and beta here, right? So now we just have to find out the value of k squared, right? For which I have to find the value of c. C by a is equal to alpha beta, as you all know, which is basically here 1.5 into 3.5, that is 3/2 into 7/2, that is 21 divided by 4, right? And c is k squared minus 4, a is 4, this equals 21 divided by 4. Thus k squared, this 4 gets cancelled, k square is equal to 21 plus 4, that's 25, and so k is equal to plus or minus 5, right? K equals plus minus 5, right? So we get that K1 and K2 are basically plus 5 and minus 5 respectively. And so not respectively, they can be either way. No one really cares. So the value of K1 square minus K2 square is basically 0, because whatever be the value of plus or minus for any a equals plus or minus t, a square is basically t square, right? Because plus minus doesn't matter. So K1 square minus K2 square becomes 0. That's the answer, right? For the third question, for the third question, this is x square plus 1 minus 2 power 2013 x plus 2 power 2012 into, I'll just expand this. I'm not ready. Not writing it up. Right. This is 2 power 4024 minus 2 power 2016 minus 2. Right. This equals 0. Has roots alpha and beta. Value of alpha minus beta power 2 power 2014 is what? Right. So for this question, the method that you follow is basically get the values of alpha plus beta and alpha beta, as you all know, right? And then square alpha plus beta, square alpha plus beta. You get a way to get out alpha minus beta the whole square from there, from which you get alpha minus beta, and then do it to a power 2014. You should actually get 3 power 2014 here. I'll show you the working how, right? So here it's alpha plus beta equals 1 minus 2 power 2013, because a is 1, b is this, right? Wait, this is minus of, because it's a plus, right? Alpha plus beta is minus b by a, and alpha beta is basically c by a, which is 2 power 4024 minus 2 power 2012 minus 2, right? Now we have to square alpha plus beta. That is basically getting alpha square plus 2 alpha beta plus beta squared equals this square. I'm just directly expanding it. This is basically 2 power 4026 minus 2 into 2 power 2013, that is 2 power 2014 plus 1, right? This minus 4 alpha beta gives you alpha minus beta the whole square, right? I've already used this earlier. I'm just restating it. So this now gives you alpha minus beta the whole square equals this expression minus 4 times of this expression, which is 2 power 4026. What does it mean? 2 power 2014 plus 1 minus 4 times of this, and 4 is 2 squared. So I'm just condensing it to write 2 power 4026 minus 2 power 2014 minus 8, right? Because this is 2, 4 into 2 is 8. And 4 into 2 power 2012 is 2 power 2014. 4 into 2 power 4024 is 4026, right? So this cancels. This cancels. You are left with 1 plus 8, which is 9, right? And 9 is 3 square. So basically, you get that alpha minus beta is equal to plus minus 3, right? And so alpha minus beta power 2014 is basically this whole thing power 2014. And since 2014 is even, plus minus doesn't matter, the answer is 3 power 2014, right? Fourth question, the value of 7, right? The value of 7 plus a plus b, if roots of the equation this are tan 15 and tan 45. So again, it's the same old equations that you're going to use. Alpha plus beta equals root 3a minus root 3a I just keep forgetting that. Minus root 3a alpha beta is equal to minus b. Right. So this is basically, we are given that alpha and beta are tan 15 and tan 45 respectively, and tan 45 is 1. So I'm just substituting beta by 1, cutting beta because anything into 1 is that anything. So basically we are given that minus root 3a is tan 15 plus 1 and minus b is tan 15, right? To get the I expect you guys to remember the value of tan 15 because it's pretty easy to remember. But if you don't, you have the formula 1 minus cos 30 degrees divided by sin 30, right? Where tan theta by 2 is 1 minus cos theta by sin theta, right? Which is basically 1 minus this is 1 minus root 3 by 2 divided by half. That is 2 minus root 3, right? In simpler terms, you kind of express this as root 3 minus 1 by root 3 plus 1. I mean, not simpler, but this another easy way to remember it, right? So basically, you get the value of tan 15 as 2 minus root 3, right? And this basically gives you alpha plus 1 equals, right? So this gives you alpha plus 1 equals 2 minus root 3 plus 1, which is basically 3 minus root 3, right? Which is root 3 into root 3 minus 1. So basically this equals minus root 3a. And so I'm just cancelling the root 3's over here. So basically you get a equals 1 minus root 3, right? Because there is a minus here. Minus here becomes 1 minus root 3 and the root 3 gets cancelled. A equals 1 minus root 3. Similarly, you have alpha equals minus b. So basically b equals root 3 minus 2. Given this, you are asked for 7 plus a plus b, which is 7 plus 1 minus root 3 plus root 3 minus 2. You can see that root 3 and this minus root 3 get cancelled. 1 minus 2 is minus 1. So this is basically 7 minus 1, which is 6. Right? The fifth question. Product of roots of equation x square minus 5kx plus 2 e power 4 ln k minus 1 is 0, is 31. Find the sum of roots. Right? So this question, you are basically given that alpha beta is 31, which is 2 e power 4 ln k minus 1 is 31, right? This minus 1 goes here, this becomes 32. This 2 cancels this out to get 16. And you have this e power 4 ln k over here, right? Again, using the same logarithmic rule of changing this base and this coefficient. You get this to be k power 4 ln e. And I hope all of you know that ln e is what, right? So this is basically 16, which is 2 power 4, right? So here you get that k power 4 is 2 power 4 and k is 2, right? Find the sum of roots. Sum of roots is basically 5k, right? Because this minus b by a is the sum of roots. Minus b by a is minus of minus 5k by 1, that is 5k, right? This is equal to 5 into 2, that is 10. The real solutions of 2 sin x equals this. This is a question where you have to use the graphing method, right? So you have on the left hand side 2 sin x, which you take as a separate function f of x, right? F of x equals sin x times 2. And the right hand side is taken as another separate function, g of x, right? That is x squared minus x pi plus pi squared plus 8 divided by 4. So this being the graph, I'm representing this as 0, this y, this x, blah, blah, blah. And so you get that fx can be represented as this sine wave, right? And just giving it until this is 4 pi. Because frankly, this is a parabola and this parabola should not extend beyond 2 pi, as you'll see when I just draw it out, right? And mark the upper bound as 2, mark the lower bound as minus 2. This is necessary because you are going to graph a parabola again. And to mark that parabola, you need to actually reference the different endpoints that you get, right? This basically 2 add pi by 2, and this is 2 pi, this is pi. I'm not marking anything else, right? So that's f of x taken care of, and now you have to get g of x, right? For doing g of x, first you figure out that this is a quadratic equation, you get a parabolic graph, right? G0 is basically pi squared plus 8 by 4. That is pi square by 4, pi square by 4 plus 2. And pi square by 4 is a non-negative number. Non-zero, it's a positive number basically. So it comes somewhere over here, right? I'm not exactly measuring it out. It's not a scale, but it comes somewhere over here, right? And check the value at pi by 2, right? Or better yet, check the minimum of this graph, right? For a parabolic graph, I hope that you guys know that the minima is given by minus b by 2a and minus d by 4a, right? If you don't, it's an easy way. It's an easy process to just differentiate this function, get the value of x at which it's a minimum, and then substitute that x to get the functional value, right? So this minima is given by minus b by 2a minus d by 4a. This is minus of minus pi divided by 2, comma, and d is basically b square minus 4ac, that is pi square, this minus of pi square minus 4 times a times c, that is pi square plus 8, and just multiplying it by the minus here, divided by 4, right? This equals this actually equivalent to pi by 2, comma, this pi square gets cancelled, minus gets cancelled, 8 by 4 is 2, and so this is pi by 2, comma 2, and that's the minimum, right? This is your minimum, right? So you have the property that there exists no point that is less than that has a functional value less than the minimum. So basically, this point marks the end of the parabolic trajectory. So whatever you have it, something like this comes down here and goes up here. So this touches this sine curve at only one point at pi by 2, comma 2. And so this equation 2 sin x equals this has only one solution, right? Because by the graphical method, when you separate it as two functions, the number of intersections of these two functions gives you real solutions of this equation, right? That's the theory behind it. So then question number 7, where you have this big determinant. This pretty easy to solve because you know the determinant properties that rho 2 minus rho 1 does not affect the value of the determinant, right? And so you have this 1ab, 1ca, and 1bc equals 0, right? And this reduces to 1ab, right? 1c minus a, b, wait, c minus a minus b, and this is 0, this is 0, this is b minus a, and c minus b, right? And just subtracting rho 2 minus rho 1, rho 3 minus rho 1. Rho 2 is the operations, R2 giving R2 minus R1, and R3 giving R3 minus R1, right? This equals 0. And so just expanding this determinant across this column, you get that c minus a times c minus b minus a minus b. This is not writing. A minus b into, wait, this is b minus a equals 0, right? This is basically minus of a minus b the whole square, right? And I just expand this to give you c square minus ac minus bc plus ab plus a square minus 2ab plus b square. This equals 0. This plus ab and one of these minus 2ab gets cancelled. So you have the equation a square plus b squared plus c squared equals ab plus BC plus AC, right? I'm not going to prove this now, but this property only holds in a triangle when the triangle is equilateral, right? So basically you have this suggestion that the triangle is equilateral. So each of A, B, C, right? Therefore, tan square A by 2, tan square B by 2, tan square C by 2 is basically tan square of 3 tan square of pi by 6. That is 1, right? Because tan pi by 6 is 1 by root 3. And tan square pi by 6 is basically 1 by 3, right? 3 into 1 by 3 is 1. Right? Question number 8. Tan of this pi cos theta, tan pi cos theta equals cot pi sin theta, right? Now, you should all know the relations between tan and cot, which is basically an inverse relation, that is tan is 1 by cot, as well as the relation that tan is pi by cot of pi by 2, cot of pi by 2 minus something, right? Basically, it's saying that tan x is cot of pi by 2 minus x, right? You should all know this relation, these relations. So this gives you that tan of pi cos theta is tan of pi by 2 minus pi sin. Why I didn't choose a 1 by thing is because that is going to complicate matters, because you then get tan something into this tan of other something equals 1, right? Beyond which you need to use some kind of an A plus B formula to simplify this, and then get some other equivalences or get some other conditions, which can just be skipped by applying this pi by 2 minus this, right? So basically you have this in the principal domain, this has to be equal to this. And so I'll just try equating these both. Pi by 2 equals pi cos theta plus pi sin theta, right? Pi cancels out. You have a half here. So you basically get that sin theta plus cos theta is half, right? I'll just write this over here. Sin theta plus cos theta is half. Now, I'm actually not concerned about the value of theta that goes on here, right? Because we are asked to find out cos square theta minus pi by 4. And cos of theta minus pi by 4 is equal to sin theta in this basically cos theta cos pi by 4 plus sin theta sin pi by 4. And cos pi by 4 equals sin pi by 4 equals 1 by root 2, as you all know. So I'm just skipping a step. This is 1 by root 2 cos theta plus 1 by root 2 sin theta, which is basically 1 by root 2 times this expression, which is 1 by root 2 times half. This is 1 by 2 root 2, right? And squaring this gives you 1 by 8, which is what is asked for, right? Now, question number 9, where you have greatest GIF of sin x plus GIF of root 2 cos x equals minus 3, right? Now you guys have to remember that sin x is bounded between -1 and 1 for all x. For all x belongs to R, right? I'm sorry if you don't know the these notations. This is for all. This belongs to. This again belongs to, and R is the set of real numbers, right? So this sin x belongs to this -1 to 1, and so GIF of sin x is any of -1, 0, or 1, right? So the maximum value this first GIF can take is basically -1. And root 2 cos x, since cos x and sin x are bounded by the same this, I'll also append cos x here. Cos x comma sin x belongs to -1 to 1. So root 2 cos x belongs to minus root 2 comma root 2, easy to see. And so this GIF of root 2 cos x is basically GIF of root 2 cos x belongs to any of -2, -1, 0, or 1. Because root 2 is 1.414 approximately, right? And -1.414, if you take the GIF of -1.414, you get 2, -2, right? So basically, the least value that this can take is -2. The least value that this the GIF of wait the GIF of sin x candidate is basically -1, right? So you have that this both the addition of this both equals -3, where the least value this can take is -1, the least value this can take is -2, right? And -1 plus -2 only equals -3. No other pair gives you -3, right? So basically you have a bound here where you are given that this √2 cos x has a GIF of -2 only, and GIF of sin x is -1 only, right? And so you are basically given that sin x is less than 0, because only a number less than 0 and less than or equal to -1 gives you a GIF of -1. And √2 cos x basically lies between -2 and -1, right? So these are the two things that are given, right? And this basically implies x lies between 2 pi and pi, right? Easy to see from the graph. And this basically implies that cos x lies between -1 by √2 and -√2, right? Cos x cannot go to -√2. So basically this can be stated as -1, right? Because there's quite no difference. Cos x cannot go over -1, right? So this basically bounds the value of x to, right? I'll draw the graph for your convenience here. This is cos x up until 2 pi. I'm sorry for the unscaled graph. So you have cos x being bounded to -1 by √2 to 1, and this -1 by √2 occurs somewhere over here, where this value is 3 pi by 4, and this value is 5 pi by 4, right? So basically the value of cos x lies between these two, which is 3 pi by 4 comma 5 pi by 4, right? And you are given that x lies between pi and 2 pi. Both these conditions should satisfy for this equation to hold true, because of which we get the bound x belongs to this open pi and open 5 pi by 4, right? Which is this option. I just formatted wrongly here. That's this option, right? Question number 10. Right. Number of principal solutions of root sin x plus this minus 1 by root sin x equals cos x, right? And this basically, when you see a root sin x and 1 by root sin x, the first thing you should think of is squaring, right? So this basically is sin x minus 1 by sin x plus 1 by sin x minus 2, because root sin x and 1 by root sin x just cancel out each other. This equals cos squared x, which is 1 minus sin squared x. This is basically sin squared x plus 1 minus 2 sin x equals sin x minus sin cubed x, right? And just multiplying the whole thing by sin x. So now you have that. I just remove the sin x, bring it to 3 sin x over here, and bring this sin cube x here to get a cubic equation: sin cubed x plus sin squared x minus 3 sin x plus 1 equals 0. Now taking sin x as t, because I don't want to write sin x again and again. It's t squared minus 3t plus 1 equals 0, right? Trial and error, putting t as 1 gives you 1 plus 1 plus 1 minus 3, right? So basically t equals 1 is solution, right? Taking that out, you get t squared into t plus, t squared into t plus 1. Now, this should be t minus 1, right? T squared into t minus 1. that gives you an excess of minus t squared, which is counted by adding a t square over here. So basically this is plus 2t squared. Wait, this plus 2t into t minus 2. Now it's t minus 1. Right? Right. This is 2t into t minus 1. That gives you a minus 2t. There is still a minus t left. So that is minus 1 into t minus 1. So basically you are left with a t square plus 2t minus 1 into t minus 1. Right? This equals 0, of course. Right? You already got this value t equals 1. And this expression simplifies to t equaling minus 2 plus minus root of 4 plus 4 by 2, right? Which is minus 1 plus minus. So, right over here, you notice that one of these two values, that is minus 1 minus root 2, is basically beyond minus 1, right? It's basically minus 1 minus root 2 is less than minus 1, right? And sin x cannot go beyond minus 1. So basically this value cannot occur. It's cancelled out, right? The other value, root 2 minus 1, is basically 0.414, which is within the bounds of sin x. So that can be a possible value, right? So sin x equals, sin x can basically equal 1 or 0.414, right? Which means that there are two principal solutions of this equation. Now a pair of dice is thrown, 5 appears on at least one die. Probability that sum is 10 or greater is a by b, right? You are given that 5 appears on at least one of the dice. So basically you have to restrict the sample space now, right? So you have one of 5 1, 5 2, 5 3, 5 4, 5 5, 5 6, or one of 1 5, 2 5, 3 5, 4 5, and 6 5 that can occur, right? These are the 6 possible outcomes that these are the 11 possible outcomes that you can have when 5 appears on at least one of the dice, right? Given this constraint, your sample space is basically 11, right? I'm not counting 5 5 again because that's a repeat count and you should not do that, right? The probability that the sum is 10 or greater occurs when it's 5 5, 5 6, or 6 5. That is 3, right? So that's 3 by 11, and you can see that 3 and 11 are co-prime. Value of a plus b is 4. 3 people A, B, C throw a dice in succession. One getting 6 wins. If A starts, the probability of B winning, right? This is a tricky problem. You have to notice that nobody stops throwing the dice when when something else occurs, right? So basically the game keeps going on until 6 occurs. So it's either so the probability of B winning is basically A losing, A dash into B, or it is A dash, A losing, B losing, C losing, A losing again, and then B winning. Or this cycle continues. Basically, you repeat this sequence twice, A dash, B dash, C dash twice, and then A loses again and B wins. And the game keeps going on, right? Any one of these has to occur for B to win. And this sequence has to occur for B to win, because A starts, then B comes, then C comes, right? So this is basically, you can see that this is basically a GP, where you have the starting value A dash B, and you have your common ratio A dash, B dash, C dash, right? And so this is basically the probability of A losing is basically A not getting a 6, which is 5 by 6, because you only have 6 7s on a die, and equal probability for each of these 6, right? That is 1 by 6, right? And B winning is basically B getting a 6, that is 1 by 6, right? Which is 5 divided by 36, right? And your common ratio R is basically A dash, B dash, C dash, which is 5 by 6, all 3 people losing. That is probability of loss, the whole cube, because they are independent events. Whatever A throws does not affect B, whatever B throws does not affect C, right? And so R is basically 5 by 6, the whole cube. That is 125 divided by 216, right? And so summing up your GP, you get 5 by 36 divided by 1 minus 125 divided by 216. That is basically 5 into 216 divided by 36 whole divided by this 216 minus 125 is 91, which basically gives you, this is 6, this is 30 divided by 91. Number 13, where you have bag containing 50 tickets numbered 1, 2, 3 till 50, of which 5 are drawn at random and arranged in ascending order of magnitude. The probability that x3 into x4 is 85 is, right? So first of all, figure out the theory that if you're arranging it in ascending order of magnitude, there is only one way you can arrange x1, x2, x3, x4, x5, because all are distinct, right? And so this arranging in ascending order is basically choosing 5 cards out of 50 and not permuting them. That is 50 C5, right? That is your sample space, right? The probability that x3 into x4 is 85 is basically the probability that you have 17 and 5 in your cards, right? This basically 85 is 17 into 5, right? And so you have the constraint that x3 is 5, x4 is 17, x4 is 17, right? This is x3, this is x4, right? Just ignore this marking. That was a wrong mark here, right? Just kidding. So yeah, this you can see that 85 does not factor any other way, and the way of 1 and 85 being factors does not actually affect anything over here, because there are only 1 to 50 tickets and not 85, right? So you have the constraint that x3 is 5, x4 is 17. Those are fixed, right? So you can choose x1 and x2 from 1, 2, 3, and 4, because these are arranged in ascending order of magnitude, right? So x1 and x2 belong to this, right? And x5 belongs to whatever is greater than 17, right? So basically you have the constraint that this is basically 4C2 into 1 into 1 into what? You have 18 till 50. That is, these are 50 numbers, these are 70 numbers. So you have 33 C1, right? Divided by the total sample space, that is 50 C5. And 4C2 is basically 4 into 3 divided by 1 into 2. That's 6, right? So this is basically 6 times 33 divided by 50 C5. These two are 1 and 1. There is no chance of this being changed. And then you have x1 and x2 being chosen from 1, 2, 3, 4. That can be done in 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, and 3, 4. That is the space. So you have that, right? And so this is basically 6 into 33 divided by 50 C5, right? I'll basically try to make this kind of like this. I'll check if C is the option, right? 50 C5 can be written as 50 into 49 factorial divided by, wait, it's 50, 49, 48, 47, 46 divided by 1, 2, 3, 4, 5, right? Where we take this out is 10 times this. Yeah, got it. So the 50 C5 is basically 10 times 49 C4, right? And so this can be written as 6 into 33 divided by 10 into 49 C4, where this cancels out to 3, this cancels out to 5. 3 into 33 is basically 99 divided by 5 into 49 C4, right? This is your option C, right? This question number 14. A man takes a step forward with probability 0.4, backwards with probability 0.6. Probability that at the end of 11 steps he's 1 step away from the starting point is, right? So this, just an extra bit of knowledge. This situation is basically called a random walk, right? Where you can step forwards or backwards with some probability, right? So if at the end of, you can't stay at the same, number. So basically, if I draw a number line over here, right? This being okay, this being marked as 0, it's not 0, right? There's some edge, right? This being marked as 0, 1, 2, 3, 4, 5, let's say. This -1, -2, -3, let's say, right? You can't simply stay at 0 in one step. You have to go to either +1 or you have to go to -1. This is not possible, right? So if at the end of 11 steps, he's one step away from the starting point, then at the end of 10 steps, he's at the starting point. Because at the end of 11 steps, only and only then can he wait. No, I should not do that. I should not do that. I should not say that. That's wrong, right? So I can't really say that because they can also be at -2, they can also be at +2, and then transition to here, right? I'm sorry for that, right? So basically, the idea is that you find the probability that he'll be at +1, find the probability that he'll be at -1 at the end of 11 steps, right? To be at -1, you have to have 6 backward steps, and 5 forward steps, right? 5 forward steps add 1 to your total count, and 6 backward steps decrease 1 from your total count, and finally you get -1. Whatever be the sequence that you take backwards and forwards, this holds, right? This is to get -1. And the same way, 6 forward and 5 backward steps take you to 1, right? So basically, the addition of these two is going to give me the probability that at the end of 11 steps, he's one step away from the starting point, right? And you can see that 6 + 5 adds 11 in both cases, right? So to find out this probability is basically choosing 6 backward steps, which is choosing 6 into 0.6 power 6 into 0.4 to the power 5, right? Because if you choose 6 backwards, the other remainings are forwards only, right? And this is basically 11C6 into 0.4 to the power 6 into 0.6 to the power 5, right? Now, adding both, we get a final probability P. Now, it's pretty easy to see that this is 11C6 into 0.6 to the power 5 into 0.4 to the power 5 times 0.6. I'm sorry for drawing 0 straight. 0.6 plus 0.4, right? Because this is a 0.6 power 5 into 0.6. This is 0.4 power 5 into 0.4, right? I'm just taking the common here. This adds to 1, so I can just ignore it, right? So I get the final probability P as 11C6, that is 462 into 0.6 power 5 into 0.4 to the power 5, right? Get this. 0.6 and 0.4 is 0.24. That power 5 into 462. That's your answer, right? Question number 58, where you have two distinct numbers between 0 and 180, probability that the average is 60, right? This question is basically simple if you know what to look for, right? So you are asked to pair up two numbers, right? So just choose one number that is less than 60, because that number has to occur in the pair, right? If you choose some number, say 40, then it has only one pair to get an average of 60, that is 80, right? What I'm basically doing is I'm choosing a k and I'm making a pair that is 60 minus k, 60 plus k. You only have 60 such choices of k, right? Because k is bounded between 1 and 60, right? Because you can't choose 60 twice because you have two distinct numbers, and so k cannot be 0, but k can be 1, and you have 0 and 180 are inclusive, so basically k can be 60, right? You have 60 choices for k, right? And so you have a total of 60 occurrences of the event where you have where you can choose two numbers from 181 such numbers, because it's 0 to 180, that's 180 numbers, 1 to 180, that's 180. plus 0, that is 1. So basically this is 181 C2, right? Which is 60 divided by 181 into 180 divided by 2. And this is, wait, I'll just make this 2 here. 60 and 180 goes 3 times. And so you are left with 2 divided by 181 into 3, that is 543, right? 1086 is 543 into 2. So basically you are asked for 2 times of 2. That is question number 16, where you have cot 7.5, right? This, you need to know the half angle formula. Cot 15 degrees is root 3 plus 1 divided by root 3 minus 1. Or if you're fond of the other form, this is 2 plus root 3, right? So, and cot A by 2 is equal to 1 plus cos A divided by sine. So you have the fact that cot 7.5 is basically 15 by 2. It is 1 plus this root 3 plus 1 by root 3 minus 1. This form is actually pretty useful because from this you can get the value of cos A and sine A. Since cot is basically cos by sine, you have that the numerator of cos A is root 3 plus 1 and the numerator of sine A is root 3 minus 1. And since cos square plus sine square is 1, you get that the denominator is basically root 3 is basically 2 root 2 for both, right? So this 1 plus root 3 plus 1 by 2 root 2 divided by this is root 3 minus 1 by 2 root 2, right? This is 2 root 2 plus 2 root 6 plus this basically 2 root 2 plus root 3 plus 1 divided by root 3 minus 1, right? Now I have to rationalize it because you have only a numerator down here. So this basically this I multiply by root 3 plus 1. I get a denominator 2. And in the numerator, I get this is 2 root 6 plus 3 plus root 3 minus 2 root 2 minus, wait, this plus 2 root 2 plus root 3 plus 1, right? Ignore the second. So this is basically root 6 plus 3 plus 1 is 4 divided by 2 is 2. This is root 3 plus root 3 is 2 root 3 by 2 is 3. And 2 root 2 by 2 is 8. And root 6 is basically root of 2 and 3. So you have this 2, which is A, and this 3, which is B. So B by A is 1.5. And B by A is 3 by 2, that's 1.5. The following statements: cot 15 pi minus theta is minus cot theta, cos 39 pi by 2 plus theta is minus sin theta, tan minus theta is tan minus tan theta, and cot square minus cosecant square is minus 1. Right? This pretty easy, right? I'll tackle this first because this is a very common identity. 1 plus cot square is cosecant square. So basically, you can see that if you take it on the other side, cot square is cosecant square minus 1. And if you bring cosecant square here, it's cos square minus cosecant square is minus 1. So S4 is true, right? S3 is tan minus theta is minus tan theta. We all know that it's only cos minus theta is cos theta, none other, cos and secant, of course. And so tan minus theta is minus tan theta, that's also true, right? S2, where cos of 39 pi by 2 is given, that is basically 38 pi by 2 plus pi by 2. That's 19 pi plus pi by 2, right? 2 pi is a cycle. So basically 19 pi plus pi by 2 is pi plus pi by 2, right? That is 3 pi by 2. So it's all silver teacups where the fourth quadrant, the fourth quadrant, this 1, this is, this is 2, this is 3, this is 4, right? So this fourth quadrant, you have cos being, you have cos being positive, right? So this is 3 pi by 2 plus theta, that is plus sin theta. So S2 is false, right? The first one, cot of 15 pi minus theta, that is again 2 pi is a cycle. 15 pi minus theta is basically pi minus theta. And since it's all silver teacups, in the third quadrant, cot and tan are positive. And this pi minus theta lies in the second quadrant, right? So you have this to be minus cot theta, that is true. right? So it's just S2 that is false. There is one false statement, right? Now question number 18. A plus B is pi by 2. This has a mistake. I'm just giving to the next question because I don't want to waste your time. Yeah. The value of cos pi by 30, cos 3 pi by 10, cos 11 pi by 30, the whole square, and this, right? So this uses the multiplication of 2 cos the formula, where you have I just read this as cos 11 pi by 30 first, right? I'll tap with this. This basically simplifies to half of cos of a plus b plus cos of a minus b, right? So that is 11 pi plus pi, that is wait, this is cos of 12 pi by 30 plus cos of 10 pi by 30, which is basically half of this is 6, this is cos 2 pi by, okay, I just keep this as 12 pi by 30 itself. And 10 pi by 30 is basically pi by 3, 10 pi by 30 is pi by 3, and cos pi by 3 is cos 60 is half, right? This is the simplified form of cos pi by 30 into cos 11 pi by 30. This is multiplied by, so basically this is multiplied by 3 pi by 10. So if I just expand this, is basically a half of this into 3 pi by 10 plus 1/4 cos of 3 pi by 10. This expands again to 1/4 of a plus b plus a minus b. So this is cos of 12 plus 9 is 21 pi by 30 plus 12 minus 9 is cos of pi by 10. Right, that is 12 minus 9 is 3 pi by 30, that's pi by 10, right? Plus 1/4 cos of 9 pi by 30. So this is basically 1/4 times pi minus 9 pi by 30. That is basically minus cos of 9 pi by 30, right? So this basically minus cos 9 pi by 30 plus cos pi by 10 plus 1/4 cos 9 pi by 30. This cancels out, and you're left with 1/4 cos pi by 10, right? That is the value of this, and this expression squared, if I write this as a squared plus b squared, right? You have a is this, right? And so a squared is basically 1 by 16 cos squared pi by 10, right? Similarly, for b square, you do sin a sin b. Sin a sin b is basically cos of a minus b minus cos a plus b, right? You follow similar patterns as to here, where since it's sin pi by 30 and 11 pi by 30, you have at first it's sin pi by 30, sin 11 pi by 30, which is basically cos of a minus b, that is pi by 3 minus cos 12 pi by 30, right? Whole divided by 2, which is 1/4 minus half cos 12 pi by 30. The next portion is basically the multiplication of sin 3 pi by 10 into this, which is sin t pi by 10 1/4 minus half cos 12 pi by 30 into sin 3 pi, this is 9 pi by 30, right? And cos a sin b is basically sin of a plus b. This is basically sin of a plus b plus sin of a minus b. This is minus cos a sin b, no? So this sin of, wait, just sin of a minus b is right, adding these, you get 2 sin of cos b, right? And so taking, right, so I have to subtract. So I just take A as 12 pi by 30, B as 9 pi by 30, get this to be sine A plus B minus sine A minus B. Right. So this is 1/4 sine of 3 pi by 10 minus half minus 1/4. Right. I'll just take half into this is sine A plus B, sine of 12 plus 9, 21 pi by 30 minus sine of this. This is 12 minus 9, 3 pi by 30. Right. So basically, again, you have these two get cancelling because sine of pi minus theta is sine theta itself. Right. And so you have this to give you 1/4 sine pi by 10. Right. So basically, in this expression, you have b to be this, that is wait. So you have b to be sine pi by 10, right? 1/4 sine pi by 10. So therefore, a squared plus b squared is basically 1/16 times cos square theta plus sine squared theta, where theta is pi by 10, right? And this is 1. So basically, this is 1/16. 20 is simple, right? Vertical pole, 5x, right? This is placed at point A on the ground. P and Q are 2 points. This is Q, this is P, right? Such that APQ are collinear, they are on the same line, even though the line is just distorted. Angles of elevation of point B from P and Q are 30 degrees. From P, it's 30 degrees. From Q, it's 45 degrees. And this is point Q. Right. So this 45, tan 45 is 1. I can directly write AQ as X, right? Because in a 45-degree angle, this is 90 degrees vertical, right? So this is tan theta is opposite by adjacent is the same. That's 1. So opposite is equal to adjacent. This is X, right? You are given that PQ is 2m. So basically, you have the fact that tan 30, which is 1/√3, is X divided by X plus 2m. So X plus 2m is √3x. X is 2m divided by 1 minus, right? √3 minus 1, right? So just simplifying this, this is 2m into √3 plus 1 divided by 2, which is m times √3 plus 1. 21. This fairly simple question. You guys have to know that a sine theta plus b cos theta is always less than or equal to root of a square plus b square, right? And when equality holds, sine theta is basically a by root of a square plus b square. It's a hard fact, not going to change. It's because of the minimum and maximum values that the sine plus cos function actually holds. You can write by differentiation if you want to as an exercise for yourself, right? So this is a fact. And so if 3 sine theta minus 4 cos theta is 5, you can see that root of 3 square plus 4 square is 5, right? And so it's basically sine theta is equal to 3/5 cos theta equals minus 4/5, right? Because it's minus 4 cos theta, right? So this k is going to basically be 12/5 minus 12/5, that's 0, right? And so k square is 0. Question number 22, where you have the solution of this, right? You see that there are pairs here. This is 4 sine square and a cosecant square. This is a tan square and a cot square, right? So I just try to simplify this using a minus b the whole square formula, where I'll take the pairs to be 4 sine squared x plus 1 by sine squared x minus 4 plus tan square x plus cot square x minus 2 equals 0, right? You can see that this is 2 sin x the whole square. This is 1 by sin x the whole square, and 2 sin x 2 into 2 sin x into 1 by sin x, right? That's 4. And this is tan into 1 by tan plus tan square plus 1 by tan square minus 2 into tan into 1 by tan, right? So this basically reduces to 2 sin x plus cosecant x, this minus, sorry, 2 sin x minus cosecant x the whole square plus tan x minus cot x the whole square equaling 0. And so you have the property for sum of squares that if sum of two squares is 0, both the squares are 0 because the square cannot be negative, right? And so basically 2 sin x equals cosecant x, that is A. And so sin x is basically sin square x is basically 1 by 2. And so this is x equaling n pi plus minus pi by 4, right? And tan x equaling cot x, right? Which also supports this this figure n pi plus minus pi by 4, right? So basically your answer is n pi plus minus pi by 4. That's right. Find the minimum value of k equals sin per 6x plus cos per 6x. A general rule to follow is, that the minimum of sin per 6 plus sin per n plus cos per n is usually x equals pi by 4, right? A way to check is differentiation, where I'll do the long method for you, right? So it's basically dy dx of the function f of x, where f of x is basically this, which is basically 6 sin per 5 x cos x plus this minus 6 cos per 5x, right? And so I'll take 6 sin x cos x common. You have left sin 4x minus cos per 4x, right? From this, you get that the different solutions to this being 0, right? This being 0 are either x being 2 and pi itself, right? Or x being n 2n plus 1 pi by 2 for cos x, this for sin x, and this is 0 when x is some kind of pi by 4. So basically, since you are just asked to find the minimum value, not the different places that the minimum value occurs, I'll just take this at 0. I'll just take this at pi by 2, and I'll just take this at pi by 4, right? At 0, the function k becomes 1 because cos x becomes 1. At pi by 2, again, the function k becomes 1 as sin x becomes 1, right? At pi by 4, what happens is this becomes 1 by 2 cube, that is 1 by 8. This becomes 1 by 8, that is 1 by 4. That's a minimum, right? So this is basically 0.25, right? Then 24, where this occurs, right? Tan x tan z tan y is here, and x plus y plus z is pi. So you are given that x plus y is equal to pi minus z, right? Taking tan on both sides, this is basically tan x minus plus tan y divided by 1 minus tan x tan y equaling minus tan z, right? Because tan of pi minus z is minus tan z, right? So this equals tan x plus tan y equaling minus tan z plus tan x tan y and tan z. So bring this to this side is basically tan a plus tan b plus tan c, x plus y plus z equals tan x tan y tan z, right? Multiplying this whole thing by tan z, I can get tan x tan z plus tan y tan z plus tan z squared equals tan x tan z into tan y tan z. So basically, from the given question, you have 3 plus 15, this is 18, plus whatever is asked for R equals 3 into 15, right? So R is equal to 45 minus 18, that is 27. Maximum of 12 sine theta minus 9 sine square theta, differentiate, right? So basically, this is 12 cos theta minus this is 18 sin theta cos theta, right? You can take 6 cos theta out. This 2 minus this equals 0, right? So either cos theta equals 0, which means that theta is pi by 2 or something, right? Or this sin theta is of 2 values possible, right? So if theta is pi by 2, the value of this expression is basically 12. Wait, this is pi by 2, or theta equals 3 pi by 2. I shouldn't forget that. So if this occurs, if pi by 2 occurs, then this is 12 minus 9, that is 3. If 2 by 3 occurs, this is basically 12 into 2 by 3, that is that is 8 minus 9 into 4 by 9, that is 4. This is 4, right? And if 3 by 2 occurs, this is basically minus 12 minus 9, that is 21, right? You can say that the maximum value is 4. There are only 3 critical points in 0 to 2 pi, and it's a cycle. So there is only 4 here. 4 is the maximum possible value. So the maximum value is 26. Fx is continuous on R. F0 is F2. Equation Fx equals Fx plus 1 will have what? Right? So this question is tricky in the sense that you have to figure out what Fx and Fx plus 1's behavior is. Let Gx Fx minus Fx plus 1 minus Fx. Right? I don't want Fx minus Fx plus 1. That just seems counterintuitive. Right? So Gx is equal to Fx plus 1 minus Fx. I'll just redefine, I'll just define a new function. Right? So now at 0, what we have is F1 minus F0. Right? And at 1, you have G1 equals F of 2 minus F of 1. So basically, G of 0 plus G of 1 is F of 2 minus F of 0. But given that the question is F0 is F2, is basically 0. Therefore, G0 equals minus G of 1. So on a graph, we plot at 0 and 2. G0 is somewhere here. This 1, right? G1 is going to be somewhere here, right? If this occurs, you have at least one root in 0, 1, because this function is continuous. And so Fx minus Fx plus 1 is also going to be continuous. So Gx is going to be continuous, right? And so it has to cross this x-axis at least once. And so you have at least one root in 0, 1. You cannot have exactly one root, because this function can be like something like this, right? Nobody knows, because that's not really clearly defined in the question. So you have at least one root in 0, 1. 27. The number of points of discontinuity and differentiability of min of this is basically, I'll just mark the answer, that's 0.3. But how I got it is by drawing the graph of it, right? So you have in 0 to 2 pi, simplifies matters a lot. So basically, I'll draw this. This is pi, this is 2 pi, this is 1. And so this is the graph of sin x. And sin inverse cos x basically goes like something like this, where it reaches this pi by 2. Okay. So this goes like this, where this is pi by 2. This is pi by 2. And it is there, it stops at minus pi by 2 at pi, right? And then it comes back to do its job till pi by 2 at 2 pi, where it again continues this p again and again, right? That's the graph of sin inverse cos x, right? And so this being the case, you have to choose a minimum of sin x and sin inverse cos x. So that is the function. Wait, can I change colors here? Yeah. So that is basically this, this. So yeah, you have this part being the minimum, right? So you can see that this is continuous. This is not discontinuous. So the number of points of discontinuity is 0. But non-differentiability is this point where you have a sharp turn, this point where you have a sharp turn, this point where you have a sharp turn. 3, right? This continues here, but even then you are given in 0,2 pi, so you don't need to care about that. So you have 3 points of this non-differentiability over here. That's 0,2. 28. 1 by x minus 1, 1 by x square plus x minus 2. Set of points where G of f is discontinuous is basically here you have to take care to know that G of f is discontinuous when f is also discontinuous, right? So x cannot be equal to 1. That's the first thing you have to note. Right? X cannot be equal to 1. 1 is already a point of discontinuity. Right? Nobody cares about gx, but fx is something you care about because it's defined as g of f of x. And if f of x is not defined, then you can't have a g of something that's not defined. Right? So f of x cannot be discontinuous. X is not equal to 1. You have already counted that. Now, to define g of f of x, what you do is this is basically this is x plus 2, right? This x plus 2 into x minus 1. That is gx. That is gx, right? So g of f of x is basically 1 by x minus 1 plus 2 into 1 by x minus 1 minus 1. That is 1 divided by, wait, 1 divided by, this is, yeah, I mean, I don't really need to simplify further, right? So this is the form that g of f of x actually takes. So now here you can see that this should not be equal to minus 2. This should not be equal to 1. So if 1 by x minus 1 should not be equal to 1, then this is basically 1 not equal to x minus 1 or x not equal to 2, right? And 1 by x minus 1 not equaling 2 is basically 1 not equaling 2x minus 2, which is x not equaling 1.5, right? Wait, this is minus 2, sorry. So this is basically x not equaling 0.5, right? Because it's a minus 2x goes this side, 1 comes this side. This is right. It is 0.5, right? So basically you have 3 points of discontinuity. That's 1, that's minus 2, that's 2, and that's 0.5. So your set is half 1. Question number 29, where you have box x plus box of minus x is continuous at x equals 2, right? So for this, you can just take the value 1.9, 2.1, and then check the continuity, because this box function, it does not depend on what decimal you take, right? 1.99 is same as 1.9, 2.0001 is same as 2.1, right? So basically at 1.9, your function is this numerator is going to be 1 plus minus 2. And at 2.1, this is going to be 2 plus minus 3, right? So at both places, it's going to be minus 1. And so lambda is also going to be minus 1 because it's continuous, right? 30, last of the maths questions. This is a 2 power x minus 1 whole square tan 3x by x sin square x, right? First of all, just remember that having x as a denominator simplifies things a lot, right? Instead of sin square x. So multiply and divide this whole function by x squared. So basically what you get is 2 power x minus 1 whole square into tan 3x divided by x sin square x, right? This you multiply and divide by x squared to get something like 2 power x minus 1 whole square divided into tan 3x, of course, 3x divided by x cubed into x square by sin square x, right? Let's just isolate this because x by sin x tends to 1 as x tends to 0, right? Everybody knows that. Now this can further be split as 2 power x minus 1 divided by x whole square into tan 3x divided by x into x square by sin square x, right? This now applying the limit as x tends to 0, right? This tends to 1. This tends to 3, right? Because tan x by x tends to 1. This basically multiplying 3 and 3 over here. So tan 3x by 3x tends to 1, and 3 into 1 is 3, right? So this function is the only thing that's left out. And this you can directly do by L'Hopital, where you have this to be 2 power x ln 2. I'm not caring about the square over here. Square is basically this multiplied by itself. So this basically 2 power x ln 2 divided by 1. And as x tends to 0, this tends to 1. This tends to 1. So basically this is ln 2, right? So you have this function, this whole thing to be equal to, 3 ln 2, right? 3 ln 2 the whole square. 3 ln 2 the whole square, right? Now you are asked to find out 10 root 3 lambda by ln 2. You get that limit x tends to 0 is 3 ln 2 whole square. So lambda is, this is equal to lambda, right? 10 root 3 lambda is basically 3 lambda is basically 3 ln 2 the whole square, and root of 3 lambda is equal to 3 ln 2, right? And 10 into 3 ln 2 by ln 2 is basically 10 into 3, that is 30, right? Thus comes an end to maths. This is physics, where I have mentioned. So continuing on this physics, where you have a V-star network first. V-star network, you all should know this. It's basically this kind of a network. This is P, this is Q, this is R, this is S, and you have connections here. You usually have some kind of a resistor over here, that is X or something, right? But PQRS, this is wrong also. So you're given that this is 2, this is 2, this is 2, this is 3, and you're asked to find the resistance with which this S, you have to find the resistance through which this S has to be shunted to balance it, right? To balance, balancing is basically the fact that P by Q equals R by S. Since P and Q are both 2 and 2, and R is also 2, S has to be 2, right? The S dash has to be 2, basically, right? Where S dash is the balanced S, right? If S and S dash, since you have a shunt resistance is always connected in parallel. And so S dash can basically be written as S plus this shunt be X, small x. This is S plus X divided by, wait, this is, so S dash is basically Sx divided by S plus X, right? So this is given to be 2, right? And this is given to be 3. 3x divided by 3 plus x is basically 2, right? Which means that 6 plus 2x is 3x, and x is 6 ohms, right? Your shunt resistance is basically 6 ohms, right? 10 volt battery with internal resistance 1 ohm, 15 volt battery with internal resistance 0.6 connected in parallel to a voltmeter. The reading in the voltmeter is going to be. It's also fairly simple, with this being 10, this being 1, this being 15, this also being 1, right? So set up this, let this be an arbitrary ground, right? Because I don't want to, confuse myself with different voltages. Let this be an arbitrary ground. This has 0 voltage. Let a current I flow through the circuit in this direction, right? So basically this is the direction of I. I'll use KVL in this loop, right? So I'm not connecting the voltmeter because I can just figure out the voltage over here. Let this be V, right? That's going to be basically what the voltmeter measures. So I have to find this voltage V. So since I have this to be the circuit ground, I can just take this 0 equals from the circuit ground, go in this loop. That is minus I, wait, this is 0.6, sorry. This is minus 0.6 I minus 0.6 I plus 15 minus 10 minus I, right? This is basically 5 minus 1.6 I. right? Therefore, I is equal to 25 divided by 8. It is basically a division where you take this to be 1.6, I equals 5, I is 25 by 8. And then this gives you the fact that V equals 15 minus 0.6 times I, which is basically 15 minus 3 by 5 into 25 by 8, which is basically 15 minus 15 by 8, which is 13.125, right, volts. So that's closest to 13.1 volt. That's the answer. Question number 33 states that this is a potentiometer circuit where you have 6-volt battery with internal resistance 1. You have a wire of resistance 5 of like 100 centimeter, right? It's uniform. The positive terminal of another battery, EMF 4 volts, internal resistance 1 is joined to point A as shown, right? The internal resistance of this battery does not matter when there is no current through the galvanometer. I'll just tell you that, because if there is no current, then you have no voltage drop across this resistor, because of which that resistor actually does not matter, right? But yeah, going ahead, you are asked to find the value of alpha for this. There is no current to the galvanometer, where you have this to be 6 volts, this to be this. I'll just consider this circuit first. I'll not consider the potentiometric device, right? So basically, you have a 6-volt battery, you have a 5 ohm resistance, and you have a 1 ohm resistance, right? This is the internal, this is the external resistance. But still, it comes with the fact that you have a net current in the circuit of 1 amp, because it's 6 divided by 5 plus 1, right? So whatever length you have here, right? The resistance offered by AB, RAB into I is going to be VAB. And since I is 1A, VAB is numerically equal to RAB, right? That is equal to whatever length this is. Let this be X, let this be, they have given it as alpha. I'll consider it to be alpha dash, right? So let this be alpha dash divided by 100 into 5, right? Because the length, total length is 100 centimeter. This alpha dash be this, and so alpha dash by 100 into 5 is going to give you your resistance of AB, right? So yeah, having gotten this, AP is equal to alpha dash into 5 by 100, right? We now have to consider this potentiometric device, where if there is no current through the galvanometer, then the potential across AP is going to be the potential across this AG also, right? Which means that this potential, which is 4 volts, is going to be the same over here, because there is no current, right? So this is equal to 4, right? Therefore, alpha dash is equal to 400 by 5, which is 80 centimeters. And so alpha is equal to 80 by 10, that is 8. That is your answer. Now, this same question, maybe answer. An ammeter has a resistance R0 and a range I. What resistance should be connected in parallel with it to increase its range by Ni? Right. Ammeter theory. Right. I'll just skip this question because I've forgotten ammeter theory. Consider a pair of identical pendulums which oscillate with equal amplitude independently, such that when one pendulum is at its extreme position, making an angle of 2 degrees to right with vertical, other pendulum makes an angle 1 degree to the left of the vertical, right? So now you have 2 pendulums. Let this be, so basically pendulum A, pendulum B, bob, right? And so it's, they both oscillate with the same amplitude A dash, let's say, right? And the same rate, identical pendulums, right? So if they're identical pendulums, they also oscillate with the same frequency. So this basically A dash sine omega t plus phi 1, that is XA, right? And XB is A dash sine omega t plus phi 2, right? So when one pendulum is at its extreme, making an angle 2 degrees to right with vertical, 2 degrees to the right, right? So you're given that the extreme position is basically 2 degrees to the right of the vertical, right? And at this position, if this is the vertical, this is this is 2 degrees, and this is the extreme beyond which there is this kind of a motion, right? This is for pendulum A. And at the same moment, pendulum B is basically 1 degree to the left of it, right? So, yeah. So now you have that this phase difference is going to be either this way, where the pendulum can travel this way, where you have a phase difference of 2 plus 1, that is 3 degrees, right? Or you can have this pendulum traveling this way, where you have a phase difference of 2 plus 1 degree, that is 5 degrees, right? I seem to think that since this question is fairly ambiguous, I'll take the least of these values and put it as 3, right? But this question is fairly ambiguous because there is some missing data over there, right? Now, these two simple pendulums of length 5 and 20 given small linear displacement in one direction at the same time. All right, two pendulums given impulse in the same direction, right? One is of length 5, another is of length 20. So basically, omega is wait, time period is 2 pi root L by G, right? So T, if this is A, this is B, then TB is going to be twice of TA because the length of B is 4 times length of LA, right? Now, after how many oscillations completed, both pendulums will be in the same phase. Now they are asking you to find out when they'll be in the same phase, right? So if this completes one oscillation, this is going to complete 2 oscillations. So after one complete pendulum, one complete thing of the shorter length, one complete oscillation, this is going to come back to its initial position, right? Because it's an integer multiple of the time period, right? And so they'll be in the same phase. Two complete oscillations of 5 gives one oscillation of 20, right? Not the other way around as well. Radius and mass of some other planet are 3 times the respective values of Earth. So basically, this is 38. Rx is 3 Re, and Mx is 3 Me. Right? Period of oscillation of simple pendulum on the Earth is 2 seconds. Then what is the period of oscillation of the same pendulum when it's taken to that other planet? Right. So T is basically 2 pi root L by G. Right. L does not change. Right. So T x, right? So Tx divided by Te is basically square root of Ge divided by Gx, right? And Gx is basically since these are 3 times, G is square root, this is Gmx by Rx squared, right? So, right, so this is basically 3 times Me by 9 times Re, that is 1/3 G into Me by 3 Re squared, right? That is 1/3 of Ge, basically. So Tx by Te is, this is root 3, right? So Tx is basically 1.73 into 2, that is 3.46. Right? That's your answer. 6. Right. And then a particle of mass m allowed to oscillate near the point of minimum of a vertical parabolic path. The angular frequency of small oscillations of the particle is, so basically this is a vertical parabola, and so you have a force of oscillation G down, right? And you have this, you have a small displacement, of course, right? So pulling that down, you take it to the side, right? The potential energy becomes, so when you just push it to the side, you get a potential energy mgy, which is mg into 4 mg into x squared divided by 4a. Right? So now the force that's going to pull it backwards is basically minus du divided by dx, right? This is u, right? This basic, this is going to be the horizontal force, right? Yeah, that's a horizontal force. That's going to be mgx divided by this mgx by 2a, right? And that's going to be the, right? Kx is going to be your mgx by 2a. That's going to be the force that's pulling it down. That's kind of like the spring force or the force of what is this? The force that brings you back to equilibrium. So this k is what is asked for. That's the angular frequency. No, this is the wait. This is the okay, fine. K is not what is asked for. K omega is asked for here. So this is mg by 2a, and omega is equal to root of k by m, right? That is square root g by 2a. And then you have the question number 40, where a uniform rod of length L, mass m is pivoted at the center. Elements attached to springs. Right. So here you have this kind of a setup where you have spring of constant k, you have a rod of length L, you have another spring of constant k, and that's attached, right? So if you pull this by some angle theta, right? Because it's pivoted here, you can only rotate this rod, right? If you pull this by some angle theta, this k, this spring, is going to be stretched by a length x theta, right? Wait, is going to be stretched by a length. This is L by 2 theta equals x, and the same is going to be the same is going to hold true here also, right? Because if this goes here, this goes here by theta, right? So basically, if you are going to pull this, if you're going to pull this rod L by theta angle, you're going to get a restoring force of twice L by 2 theta. That is basically F restoring, right? F restoring is equal to this is what L theta, right? L theta into K. So, right, I don't really need the restoring force, I need the restoring torque. So basically, if this is pulled by L by 2 theta, you have a torque generated about this point of a force L by 2 K theta, right, into L by 2. And that is multiplied twice because whatever is generated here is compounded by this, right? It adds. So basically, you have a tau restoring of L square K theta by 2, right? And this is basically I alpha. For a rod of this format, basically I is equal to ml squared by 12. So basically alpha is going to be k theta 6k theta by m, right? Where m is the mass of the rod. So now you have alpha, and then alpha is equal to something into theta. Angular frequency is basically square root of 6k by m, right? And so time frequency is basically 1 by 2 pi into omega, that is 1 by 2 pi root of 6k by m. Right? Observer standing here, right? Frequency 2.2, 1.8, the train approaches. This is your Doppler effect question, classic Doppler effect question, where you have F equals what? F into V, Fs, frequency of source into V, divided by, it's V plus minus Vs, right? So it's V plus minus Vs, where it's minus if you approach and plus if you plus if the source recedes. Okay. So now it's basically this is your F observed, right? This is your source, and so you have a 2.2 kilohertz being F source into velocity divided by 300 this 300 velocity sound divided by 300 minus Vs, and 1.8 is equal to F source into 300 by 300 plus Vs. So basically you have the fact that 300 minus Vs by 300 plus Vs is 118 by 22. That is 9 by 11, which means that 300 minus 11 Vs is 2700 plus 9 Vs. So basically bring this to this side, this becomes 20 and this becomes 600, right? Vs is 30. Now, yeah, 42, where an observer, right? So you have VO is equal to Vs by 5. It's V by 5, not Vs, V source, right? And you have this being lambda, lambda is lambda, Fs is F. Apparent frequency, apparent wavelength, V apparent is equal to V naught VO into V plus VO by Vs, right? No, it's V plus Vs by V, sorry, which is basically 1 plus Vs by V. That is this 1 plus VO by V, not Vs. That is V by 5 into 1 plus 1 by 5. That is 6 by 5, right? This is 6V by 25. If apparent is VA minus VO by VO into 100. This is basically this is 6 by 5 VO. So this is 1/5 of 100 because it's 6 by 5 minus 1. This is basically 20%, right? So if F increases by 20%, then what happens to lambda? Wavelength recorded, speed of sound, wavelength recorded stays the same. Wait, frequency stays, there is a shift in frequency. There's no shift in the wavelength. So it's basically 1.2 F and lambda, right? Because the velocity changes with frequency and so lambda does not change, right? And I have no time remaining, so it's going to be separate soon, right? So two corrections, right? First of all, in 36, I would have said that this is 3, right? It's not 3, but this is actually, this has the values either 120 or 150, right? 120 degrees or 150 degrees, because they've asked for phase difference. And before I calculated for the amplitude difference, right? So here it'll be, it's basically, this is an amplitude, this is a phase of 90 degrees, right? Considering vertical to be 0. This is a phase of 90, and this 1 degree half is a phase of 30 degrees, right? So it's basically, this is 90, this is 90, and this is a 30, right? This is a 30-degree phase, right? So this is from here, from this position, it has a phase of either 90 plus 30 or 90 plus 90 plus 60, right? Where, wait a minute, it's not 150, it's 200. So it's either 120 degrees phase or it's 240 degrees phase difference, right? So you have the fact that this phase difference is going to be 120 degrees, right? Because a 240 phase difference means that B follows A by 120 degrees, where a 120 phase difference means that A follows B by 120 degrees. That's it, right? So your answer is going to be 120, right? And for question number, for question number 35, here the emitter has a range R0, a resistance R0, a range I, right? So if you have to increase this range by Ni, then the new current that has to flow is going to be I plus Ni. So basically, to actually visualize this, you have to provide a shunt resistance R0 divided by N, because the construction of a construction of a meter is basically like that. And to increase this range by Ni, you basically shunt it by R0 by N. That's a standard result, right? So that takes care of 35. And then we went to question number 42, right? So now question number 43, where a train approaches a stationary observer, right? The apparent frequency of a whistle is, right, let's just expand this, approaches the stationary observer, whistle is in the air. So this is something that we did earlier also. Basically, the apparent frequency n as it moves with the observer, right? So it is something like your f1 is basically n dash, which is nb divided by, yeah, the apparent frequency n when observer moves the train is basically the natural frequency of the train whistle itself. So basically, if you take fs as n, there's going to be no change because that's going to be true, right? So this is v minus vs, and f2, that is n double dash, is nv by v plus vs, right? So you get n by n dash is equal to 1 minus vs by v, and n by n double dash is 1 plus v by vs by v, right? Adding these two equations, you get n double dash plus n dash divided by n dash n double dash times n equals 2. So it's basically option 3, 2n dash n double dash by n dash plus n double dash, right? That is 43. Now 44, a train moves to a stationary observer with speed 34. Train speed is radius is 17. The frequency is started at f2, right? Ratio of x1 and f2. This is basically 19 by 18, right? And I'll show you how they arrived at it. So now it's 45, where you have apparent frequency to be f1 is moving towards, right? Moving towards speed 34. That is v into f divided by v minus 34, right? And f2 is basically vf by v minus 17, right? So f1 by f2 is going to be v minus 17 divided by v minus 34. And since v is given as 340, this is basically 323 divided by 316. Wait, this is 306, I'm sorry, 36. This is 19 divided by 18, right? So 4 is your answer. 46. A short bar magnet, magnetic moment 0. B is equal to 0.4. It's given by 0.4 joule per second. So magnet in stable equilibrium when potential energy is basically, wait, stable equilibrium is for mb mb cos theta, but theta is 0, right? So it's for stable equilibrium, the potential energy is basically minus of r mod m into b, which is basically 0.4 into 0.16 with 0.06 minus 0.064 joules. That's one, right? Question number 47. Current I flows in a rectangular shaped wire. So they have asked for the magnetic dipole vector. So basically, construct a steel wire, wire frame. A, this is B, this is C, this is D. Let's say this is x0 plus D minus A minus B. This is x0 minus D, A minus B, blah blah. Right? So basically, from this you have to calculate. Yeah, you have to calculate each side, and then you have to do the magnetic dipole vector side. Yeah, the right. So this side is going to be, this side has what? This is x0 plus d to x1 minus d. That's the difference of 2d, comma, a vector is 2d, then minus 2a, 0. So, and cd vector is going to be the same, right? So basically, mod AB is 2 root of d squared plus a squared, and your S vector, that is your aerial vector. The aerial vector is going to be BA cross it's AD, right? So this is basically 2D minus 2A 0 cross AD is basically D minus A, that is 0, 0, which is vector minus 4B times A, comma, wait, this is basically minus 4BA minus 4BD and 0. So that is your aerial vector. And then your magnetic moment is going to be current times the aerial vector, which is basically 0.03 into this is minus 4BA. That is minus 4 into 5 into 10. That's minus 200 I minus 0.03 into minus 4BD. B into D. That's 120 and that's 480. 480 Jacob. And magnitude of M is going to be 0.03 times magnitude of S, that is 4 into 10 into square root 5 square and 12 square, that is 13, which is basically 13 for the 68 into 0.3, which is 20.0. That's your answer. One has magnetic field 15 millimeters, right? So you have two magnetic fields apply to each other, right? So you have one here. The angle between them is 35 degrees, right? So let this field have this kind of this value, and you have your dipole over here, which is inclined to this field at 30 degrees. So basically, this information is for 30 degrees, right? So field B1 exerts torque MB1, which is basically torque of 15 into M, and that into sine 30, that is divided by 2, and this is balanced by the counter torque produced by the second field of magnitude P1, let's say, right? Because this is in equilibrium. So this basically B1 M divided by root 2, because it's an angle of 45 degrees, right? So MM cancels out, root 2 cancels out. So basically B1 equals 15 by root 2 millimeters, right? Which is close to 11. This is basically 10.6 MT, which is close to 11. That equals 48, 49. This is basically a theory question. Protecting sensitive equipment from an external magnetic field. So the theory behind this is basically that the external magnetic field should not penetrate whatever you do to the equipment. So since magnetic fields do not penetrate ferromagnetic substances, and they just the lines of force just go over the surface of it. So you place this kind of a sensitive equipment by placing it inside an ion can, right? That is I think it's called magnetic screening, if I remember it correctly. So yeah, that being done, let's go to 50, where B is magnetic field inside a loop of area A, and its magnetic dipole moment is found to be NBA power M. Okay, so it's basically the magnetic dipole moment of a circular wire, right? So it's basically I pi r squared, where I is not I by 2 pi r, right? It is not either 2r. So this is basically Not I is basically 2RB divided by mu naught. So your expression is going to be 2B pi R cubed divided by mu naught, right? That is magnetic moment M, right? And you are given B, you are given the area A, right? That is pi R squared. So this expression you have to simplify to this form where N equals 2 and you generate, you divide it by root pi, make this 3 pi by 2 and you make this E cube. No, this A power 3 by 2, right? So it's basically 2 plus 3 by 2, that is your answer for M plus N is basically 2 plus 1.5, that's 3.5. This is uniform time varying magnetic field, right? At a distance R. So this is basically the induced payment. Yeah, or this is basically the induced electric field because of a time varying magnetic field outside this magnetic field, right? So this, yeah, so this is basically something that's produced. You can consider this to be something that's produced at the edge of the magnetic field, basically. So this drops off as 1 by R. So option 2 is correct, decreases as 1 by R. At R equals A, you will have A by 2 dV by dt. But beyond A, this is going to be something that's that decreases as 1 by R because it's not going to be dependent on the magnetic field. And 53, a wire carrying current I has shape as shown. R is lying the visor plane, magnetic field at O is right. I know solving this kind of question before. This option 2 is correct, right? So this is question number 53, where you have a wire carrying current I in the shape two linear paths and the semicircular part which is in the visor plane. So basically, you have this to compound here. This is mu naught I by 4 pi R. This is going to be in the direction of minus k cap. This is going to be minus k cap. This is equal to B1, where B1 is due to this part, right? This is equal to B3 also, where B3 is this part, right? And B2 is going to be due to the circular part, which is going to be outside this plane, which is along x plus I. Right? Wait a minute, no. It's going to be inside. That's minus I. I'm sorry. Right. So B2 is going to be due to the circular part, which is half of a full the semicircle. It's half of a full circle, which is minus mu naught I by 4R, right? Because this radius R into I cap. So this is basically mu naught by 4 pi into IR into pi I cap plus 2k cap because both are minus, right? So on option 2 is right. Coming to question number 54, where you have current flowing in a conducting wire shaped as shown. Value of magnetic field is basically right. It's basically due to this wire, and this semicircle part, right? So this is 3/4 of a semicircle. This one, this, right? This has no effect. This is a semi-infinite wire, right? Which produces mu naught I by pi R by 4 pi R, and this produces mu naught I into 3 mu naught I by pi R into 3 by 4 pi. So K is basically wait it's 3 by 4 into, so basically out of this part, I'm not considering this, the 3/4 of a circle plus the semi-infinite wire, that's B1 plus B2, right? B2 is directly mu naught by 4 pi mu naught I by 4 pi R, where it's capital R, right? And B1 is going to be mu naught by 4 pi into 3 pi by 2 by R, right? And so it's, yeah, and so you get the answer to be mu naught by 4 pi times 3 pi by 2, wait, it's mu naught by 4 pi R times 3 pi by 2 plus 1. Taking this inside is 3 pi by 8 plus 1 by 4. Value of K is 3 by 8. As before. Now coming to 55, where you have an electric field of 300 volts per meter confined to supply area 10 centimeter in diameter. So using the concept of electric flux, right? You have d phi by dt, d phi e by dt is basically flux. Field is increasing at a rate of 20 volt per meter seconds. So the flux over the whole field is 20 into pi r squared, right? Pi r squared, and r is 5 centimeters. Now B is equal to mu, it's mu epsilon or d by t, d phi by dt, that is this by 2 pi r, right? This by 2 pi r. This is basically substituting everything here. This is going to be 1.85 times 10 power minus 18 Tesla. So B is basically 1.85. Right? This is D. So that is 45. Then 56 is going to be effective capacitance of two capacitors C1, C2 connected in parallel. Right. So C1 plus C2 is basically 25 by 6 times the effective capacitance of series. C2 by C1 plus C2. So basically, you have the fact that C1 squared plus C2 squared is equal to 25 by 6 minus 2, that is, this is 13 by 6 C1 C2. C1 by C2 plus C2 by C1 is basically 13 by 6. Right? How do I define this now? So C1 minus C2 the whole square is going to be C1 square plus C2 square minus 2 C1 C2, that is just C1 C2 by 6. Right? And so we have C1 plus C2 whole square is equal to 25 times C1 minus C2 the whole square. So C1 plus C2 is 5 times C1 minus C2. So 4C1 is equal to 6C2. C1 plus C2 is 3 by 2, 1. Right? Parallel plate capacitor is connected to 15 volt battery and charged. Battery is then disconnected. A glass slab is introduced between plates. The quantities that decrease are the charge does not decrease, but the capacitance and the potential difference decrease. Right? Because the charge is immutable unless you have another voltage source introduced. So it's 3. 58. 40 mAh capacitor is a defibrillator. Right. And so you have a duration of 2 milliseconds. Right. You have an energy of half CV squared. That is half into, what do we see? 14 10 power minus 6 into B squared, that is 9 into 10 power 6, that is 180 joules, right? The power delivered is going to be 180 by 2 kilowatts, that is 90 kilowatts. 59, a 2 volt battery is connected to parallel plate capacitor of 4 mAh. So yeah, Q is basically, at first it's CV, where you have this is 8, and then C dash is going to be, right, it's E naught A by B, B minus T into 1 minus K, right, 1 minus kappa. So basically C divided by 1 minus T into 1 minus kappa by D, which is basically 4 divided by 1 minus T is 3 to 1 minus kappa, right? Kappa is 2 here. Then we will 600. Yeah, this is 1 by kappa. 1 by kappa. 1 by 2 divided by D is 5. So this is 4 into 5 divided by 5 minus 3 into 2 by 3. That is 20 divided by microfarads. Right? Given this to be the new C, you have the addition. You have the new Q dash equals 13.34 microcoulombs, because this into your initial charge, that is 2 volts, that is your that is Q, and so you have an additional charge of Q dash minus Q equals 5.34 microcoulombs. That's your answer, right? And 60, the last question of physics, is going to be the energy stored in capacitor between terminals A and B, right? For this capacitor. So actually, what you can do is redraw this whole network like this. Right? This is the 10-volt battery. You have at this point separation between two, right? Separation as a C, another C, giving another C here, giving another C here, and having a C in the middle, right? So basically, this becomes a Wheatstone bridge where it's balanced also. So you can just ignore this, right? This is an equivalent capacitance C by 2. This is an equivalent capacitance C by 2. This combines to give C. So basically, your energy stored, the net charge that flows is yeah. So when you do this, you can see that this is a parallel network of capacitors, and so the net charge that flows here is going to be this is going to have a potential of 5 volts because it's equal, right? This is 10, this is 5, this is 0, and this also 5. So basically, we are going to have a charge of C times 5, and since C is going to be 1 mu f, you have you have an energy of half into 1 into 5 half CV squared. That is 5 squared. That is 12.5 microjoules, right? That's your answer. Now, BF3 LILH4 is X plus LIF plus ALH3, where X is basically B2H6, right? Having identified B2H6, which of the following is incorrect? It can react with NH3, that's correct. Its dipole moment is 0, that's correct. Vacant orbital is not involved in bonding, that's wrong. And it's electron deficient. So 3 is correct. Boron exhibits a maximum covalency of 4. The number of double bonds in borazine is 62 is 4, 63 is 3. In diborane, how many hydrogen atoms account for bonding in bridges? Diborane is basically BHB, HB, H, 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 H. This is not a double bond. So there are 2 hydrogen atoms in the bridges. That's 2. Right. Following statements is correct. This is right. Aluminium does not react with dilute hydrosulfuric acid. AlCl3 at high temperatures, that is, I think that should give AlCl and not Al2Cl3, right? More salt is FeSO4 plus NH4 twice SO4, 6H2O, right? This is correct. And AlCl is not stable until 800. AlCl is pretty volatile. So this 3. Which of the following is not a complex compound? That's 3. It's easy to see. Showing maximum metal carbonyl strength. So it's this is a matter of metal ligand electron transfer, also called back bonding, of course. Right? If central atom is electron rich, there is a higher possibility of there being back bonding and metal donation of pi star orbital of CO. Right, that's the theory behind it. And so here it's FeCO4 2 minus, that is going to be the best back bonded, because Fe already has 26 and another 2 electrons are added to it because Fe has a net charge of -2 here. So it's going to be the most electron rich compound, electron rich center. So FeCO4 2 minus has the maximum VC bond strength. Right. VC bond distances and VCO6 minus are respectively 200 and 193. Again, due to the same reason, right? Prussian blue is a deep blue pigment. It's Prussian blue is basically right. 69 is Fe4, Fe3, CN6, right? So this being the case, for every formula unit, you have Fe4, Fe, and Fe6, right? So for every formula unit, you have 4 Fe3 plus and 3 Fe, wait, 4 Fe2 plus and 3 Fe, wait, what did I say? It's 4 Fe3 plus and 3 Fe2 plus ions, right? Now, which of the following ligands are of sigma donor pi acceptor? So pi acceptors need a double bond, right? So here CO, Cn minus, C2H4, C2H2 are all pi acceptors. I'm not sure about sigma C3H5 minus though. Right. Pentadienyl should be a pi acceptor, right? It has is this, since it's cyclopentadienyl, right? Since it has, yeah. So since it has this kind of thing, if you donate one of its, if it gets back a pi accepting state, it becomes anti-aromatic, and so it does not do pi acceptance. It has only sigma donation, right? So phi is basically ruled out, right? Sigma donors here is basically I think it's CO and Cn minus 1b, and so it's basically 3 and 4. So the following is correctly matched. That's 71 is basically Cu2 plus has 29. It cannot be diamagnetic because it has odd number of electrons. Ni2 minus is Ni2 plus and a strong ligand. So it's 28 electrons, and this compound is diamagnetic because Cn minus is a strong P ligand. MnCl4 2 minus is Mn2 plus, which is 25 electrons, cannot be diamagnetic. FeCN64 minus is Fe2 plus 26 electrons with a strong field ligand, that's diamagnetic. So 4 is the answer, right? Number of unpaired electrons in MnH2O62 plus is 5. COF6 3 minus, you have CO3 plus, that is 26 electrons with a weak field ligand, and so you have 4 number of unpaired electrons, right? Sedgwick EAN rule and still is an oxidizing agent, right? For 74, right? VCO6 is basically 23 electrons plus this is 12 times 2, right? This 6 times 2, that's 12. So you have 35, right? CrCO6 is 24 plus 12, that's 36, right? NiCO4 is basically 28 plus 8, that is again 36. And FeCO5 is 26 plus 10, that's 36, right? The only thing that does not follow Sedgwick EAN is VCO6, so 1 is the answer. 75 is delta O for the following compounds is basically 3 to 1. It's 3 greater than 2 greater than 1. 1 is the answer, right? Which of the following is correct? Value of acidic factor P regarding Arrhenius equation decreases as complexity decreases during any engagement reaction. So since here you have the they say that the complexity of reacting molecules decreases, I take it to mean that the steric complexity of reacting molecules decrease, and so 1 has to be true because steric factor P is basically regards the size of the molecule itself. So 1 should be true, right? And you can say that 2, 3, 4 are blatantly false because 4 N2 is not a catalyst exactly, right? And 2 and 3 are false, right? For a first order gaseous reaction, 77 log 10 K1 part against 1 by T gives a straight line with slope of minus 8,000. Calculate the activation energy of the reaction. So it's Arrhenius equation is Ka e power minus A by RT, right? And so you get log K log A So this is it is straight line with slope of minus 8,000, and this slope is basically minus EA divided by R. Now the activation energy is this is minus 8,000. So EA is equal to 8 into 2 kilocalories, which is 16 kilocalories. Right, 16 is your answer. That is 77, 78. Activation of energy can be determined from ln K versus 1 by T. The rate constant, Arrhenius constant of a chemical reaction are 4. The value of rate constant as T tends to infinity is. All right. This is 79. So this is K is A power minus A by RT. That's you have K at 25. All these. As T tends to infinity, this tends to 0 and K tends to A, right? So the value of rate constant tends to 16 into 10 power 14%. Again, this is Arrhenius parameter is 610 power 14, rate constant as T tends to infinity is 610 power 14, same as above. Anisole SI cold, of course, this is 81 now. Anisole, as you all know, is this is CH3. This plus HI will always make phenol and methyl iodide, because this I minus cannot come in set here. SN reactions are not permitted over here. Right? I cannot come in, just displace OCH totally. Right? You cannot form methyl iodide and CH3OH. No, it forms phenol and methyl iodide. Right? 3 is the answer. For maximum rate of reaction, this is basically a test of electron withdrawing groups, right? Because it's OH, this is the nucleophilic substitution over here, right? You need electron withdrawing groups for this to have happen at the maximum rate, and so X and Y are anode. Correct order for reactivity of nucleophilic substitution is again more the number of electron withdrawing groups, better is your reactivity, and so B takes over C, takes over A, takes over D. So B, C, A, D, 3 is your answer, right? Benzyl chloride prepared from toluene, simple. Since for 84, you have this compound. This is toluene, right? And so here you're going to prepare this compound. This is prepared by chlorination with Cl2 in the presence of sunlight, right? Because you're not substituting on the benzene ring, you are just doing a free radical substitution over here. So Cl2 in the presence of H2 is enough. Not SOCl2, not PCl5, not NaOCl, nothing. You need just Cl2 and H2. Yeah. Right. 85. Hydrolysis moves steadily. That's almost the same as 83, right? And you get 4. 4 is your answer. 86. Compound which contains ionic as well as covalent bonds is KCN, because CN has covalent. K plus CN minus, that's an ionic bond, right? Interactions is not part of van der Waals interaction, is an ion dipole, right? Formal charge on SN in SnCl3 is a tricky question, right? Where SN is bonded to Cl, Cl, it has minus, right? So SN is basically a 4. So each Cl has a formal charge of -1. Number of valence electrons is 4. You have a number of bonds is 3, and the number of lone pairs, the number of lone electrons is 2. So that is 4 minus 5. That is -1. 89. Here you do not calculate the number of lone pairs, but you calculate the number of lone electrons, where you multiply 2 into the number of lone pairs. It's a number of non-bonding electrons basically. Right. For 89, you have X being you have the black solid being boron, right? X being Mg2B3, which on hydrolysis gives you MgOH twice and B2H6, of course, riborin. And then Z is basically, this is Y, And Z is where Z is BH3CO, the compound formed on reaction with carbon monoxide, right? This this compound, this basically looks like BCO and then H and H, right? This way, this should be a wedge. This should be a dash. Right? So basically here, if you see this, CO lie in the same plane, COB are in the same are in one line, and then this H or this H, they'll be in the same line, right? So the same plane, in the same plane, you can have 4 atoms maximum. So 1 is the answer, right? Y has no electron deficiency is false because B2H6 has an electron deficiency. X is not a covalent compound, it's ionic, and Y does not have 8 2 electron bonds, right? And the last, how many compounds contain no covalent bonds? That's KCl only. The others all have covalent bonds. So you have this one ionic compound. So the answer is 4. Okay, that's it. That finishes the question paper. Thank you, guys.